Hello, my dears. So this is your Wednesday math for May 6th. Let's go. Again, we're asked to find the greatest common factor, the GCF, of 12 and 16. Go ahead and put that upside down division sign. What's going to go into each of these here? Well, I know that 4 will go into both of those. 4 goes into 12 3 times, and 4 goes into 16 4 times. So, is there anything else that we can get to go into both of these? No. That means your greatest common factor is 4. Next, we have some multiplication of decimals. I'm going to ignore the decimal point right now. And so we've got 7 times 2, which is 14. Then 7 times 2, which is 14, plus 1 is 15. 4 times 3 is 12, plus 1 is 13. 7 times 1 is 7, plus 1 is 8. Okay? Now, all this is going to be 0. So it's going to be 0, 0, 0, 0. Add it up. You're going to have 8, 3, 5, 4. Now, count the places to the right of the decimal point. There's 2 here and 1 here. Add them together, you get 3. You're going to start at the end of your whole number and count left 3 places. 1, 2, 3. So your grand total will be 8 and 354 thousandths. Okay? Okay. 3/4 times 2/8. For multiplying fractions, you're just going to multiply straight across the top, multiply straight across the bottom. 3 times 2 is 6. 4 times 8 is 32. Now we have to think, how am I going to reduce 6 32s? Well, they're both even numbers, so you can always start with 2. So let's divide each of these by 2. So 6 divided by 2 is 3. And 32 divided by 2 is what? 2 goes into 3 one time. 2 goes into 12 6 times. Now, is there anything that we can get to go into both of these? Nope. That's your answer. Now, we're going to divide some decimals. So we've got 0.24 divided by 0.04. Now you know that you cannot have a decimal in your divisor. So you're going to come over the exact number of spaces. Drop the zeros. 4 goes into 24. How many times? 6 times. Easy peasy. Next, we're going to look at comparing some decimals. So, okay, you're going to start with your largest place value. So we've got 7 tenths here, 7 tenths here, matching. 8 ones here and 8 ones here. Still matching. Then we have 9/10 here and 9/10 here. Still matching. We have 0 hundredths here, and even though there's no 0 here, there's 0 hundredths here, which means these are equal. Remember, in decimals, you can add as many zeros to the end as you want, and it's not going to change the value. All right, next we're going to compare some fractions. 1/8 and 5/8. Now you can do the butterfly method, but the key here, and what will let you do it in your head, is that your denominator is the same here. So you can really just compare your numerators. What's the bigger numerator? Bam. Now we're going to simplify a fraction. 14/24. Okay. Now, we can definitely do 2 because it's an even number. So 14 divided by 2 is 7. And 24 divided by 2 is 12. Now, is there anything else we can get to go into both of those evenly? Nope. So that's where we stop. This is our answer. Okay. Now we are going to simplify another fraction. 6/32. Now both of these are even numbers, which means I can divide them by 2. So 6 divided by 2 is 3. Sorry, my board started to shake a little. Okay, and 32 divided by 2. 2 goes into 3 one time. 2 goes into 12 6 times. Ooh. Oh no, 16. Sorry. 16 times, not 6 times. Now, is there anything we can get to go into 16 and into 3 evenly? Nope, that's our answer. All right, now we're going to simplify the fraction 5/100. Now you know that if numbers end in 5 or 0, that it's divisible by 5. So let's divide both of these by 5. You guys know 5 divided by 5, 5 goes into 5 one time. Okay? Now you can do it like this. That's totally fine. But I want you to think, what are all the ways you can make 100? If you want $100, what could you divide it by to have 5? By 5. So 5 goes into 10 2 times. 5 goes into 0 0 times. 1/20. 5 20s make up 100. 10, 20, 40, 60, 80, 1. All right, now we are going to divide our fractions using keep, change, flip. So 3/4 divided by 2/8. Okay? Ready? Keep, change, flip. Keep, change, flip. So that's going to be 24 and 8. How many times does 8 go into 24? 3 times. Done. Okay, here we are looking at another model. Okay, so we have this. Which is 2, because these are 2 holes, and 1/2. Oops, right down here. 2 and 1/2. Okay, then we have all these little pieces. I'm not even gonna flip them all up. But what did they divide these into? What did they make these into? 4ths, right? So you're not really worried about the shading because the shading is how you get the answer. The shaded ones is the answer. But we're not asking for the answer. We're just asking, what does this model represent? 2.5 divided by 1/4. Is that it? Ooh, you guys are having an easy week this week. Okay, see you Thursday.